discussion about chemical kinetics, chapter number 3, class 12. Expression of rate constant of first order reaction. This is very important question. Many times it was given. 4 mark will be given for this question. First take one example of first order reaction. A, P. A is reactant, P is product. Concentration, when reaction will be started, concentration of reactant will be decreased and concentration of product will be increased. Rate will be rate constant into concentration of reactant. Order will be 1. Again, the rate will be dA, concentration of A divided by dt. As the concentration of reactant will be decreased, so one negative symbol will be given here. So equation number 1, equation number 2. So equation 1 and equation 2 both are rate of reaction, so both will be same, will be equal. From 1 and 2 we get minus dA by dt is equal to K concentration of reactant. Cross multiplication, minus dA by A is equal to K into dt. This will be equation number 3. Question number 3. Integration of equation number 3 minus integration A dA by A is equal to K is constant integration dt. Formula will be ln concentration of A is equal to Kt. One constant will be given. This is equation number 4. Write down the note. Before starting the reaction, final concentration of reactant will be equal to initial concentration of the reaction when time was 0. That means at the beginning, before starting the reaction, time will be 0 and the final concentration of reactant will be equal to the initial concentration of the reaction, reactant. So before starting the reaction, that means in beginning, when time was 0, that means before starting the reaction, final concentration of reactant will be the A0. That means final concentration will be equal to initial concentration of reactant. So putting this value in equation number 4, we get, from equation number 4 we get ln A naught, A will be A naught and K when time was 0 plus C minus ln total concentration of reactant is equal to C. Putting the value of C in equation number 4, from equation number 4 we get ln concentration of A is equal to Kt minus ln A naught, total concentration of reactant. Kt minus ln A naught is equal to minus ln concentration of reactant. Kt is equal to ln A naught minus ln A. ln A naught minus ln A, that means ln A naught divided by A. We have to determine the value of rate constant. That means K will be equal to, Kt is equal to ln means 2.303 log this value A naught divided by A. We have to determine the value of rate constant. So rate constant will be equal to 2.303 divided by time log A naught divided by A. This is the equation of rate constant of first order reaction. Write down the note. If there will be any question, you can ask question at any time. I will try to answer. Comment in the video. Again you see initial concentration of reactant A naught is equal to A. Suppose initial concentration of reactant A, total concentration is equal to A. After time t, x amount of a reactant is converted to product. So final concentration will be final concentration will be A will be total concentration minus X. Therefore, a rate constant will be 2.303 divided by time log initial concentration divided by initial concentration minus X. This is another equation of rate constant of first order reaction. Okay, write down the name. This note is very important. If there will be any question, you can ask.